All right, welcome back. Today we are starting the next chapter, chapter 6. And in class today, I gave out a pink paper. This pink paper, the front side is exactly the same. It has the unit circle on. I just figured if I was printing a paper, I might as well put this on it. The back side is where it gets different. Okay, the back side has these identities. Okay, and we will use these this chapter and into the next couple chapters. But you pretty much need to have these. So if you are not at school today, make sure when you get back you ask me for this paper so you have these identities for you. Okay. Now, the first thing we're going to do is on the front side here, we're going to practice simplifying these identities and we're going to verify. Now, think back on your iPhone or your Android or whatever smartphone you have. If you are signing into an app, sometimes it asks you to verify your identity, right? What it's doing, it's double checking, making sure you really are the person that you say you are. Okay, so to verify, we are simply double checking, making sure it really works. Okay, now we are not going to manipulate anything on the right side, just change the left. So here, sine of theta, I'll just leave that as is, sine of theta, but I'm going to put it over 1. Okay, times, now cosecant theta, if we look here on our original yellow sheet or it's on the pink sheet, at the bottom here, these trig identities. So cosecant of theta, if we look right here, is the same as 1 over sine. So I can do 1 over sine of theta equals 1. Okay, at this point, we can simplify. Sine, cancel. We're left with 1 over 1, which is 1, and 1 equals 1. Is that true? Yes, so we have verified. All right, on to the next one. So the next one starts with secant. If we think about secant, secant is 1 over cosine. So 1 over cosine of theta times, now cotangent is cosine over sine. And all of that equals cosecant of theta. So at this point, the cosines cancel, and we are left then with 1 over sine of theta. And if we think about it, 1 over sine of theta, if we go back here, 1 over sine of theta right here, that is cosecant. So I can verify it. I show that the cosecant of theta does indeed equal what we started with, which in this case was secant of theta times cotangent of theta. All right, if you'd like, pause it and try the next one. But cosecant, if I rewrite that, it's going to be 1 over sine. Tangent is sine over cosine. Cotangent is cosine over sine. And finally, then cosine over 1. And all of that will be cotangent of theta. So we go to reduce, and sine cancel, cosine cancel. We're left with cosine times 1, which is just cosine, all over sine times 1, which is just sine. That will equal the cotangent of theta. Okay, and at this point, cotangent is the same as cosine over sine, so cotangent of theta equals cotangent of theta, and we are done. We have verified it. Okay, number 4 is very easy. Sine of theta over cosine of theta, that's the same as tangent of theta. So tangent of theta equals tangent of theta. Yes, that's true. Number 5, cotan, we can rewrite as that's the cosine of theta over sine of theta divided by, because if it's a fraction here, that's the same as dividing. Now cosecant is 1 over sine. But we're going to take the reciprocal of that because dividing or multiplying by the reciprocal is the same as dividing. Okay, so in our case, if we do the reciprocal, we'll have cosine over sine times sine over 1. The sines cancel, and cosine of theta equals cosine of theta. All right, this next one, cosine of theta squared over 1. If we square something, it's still the same thing, like cosine times cosine. So it'll still have the same general identity. It's just now it's squared. So tangent is squared, just like 5 squared is 5 times 5. Tangent squared is just tangent times tangent. We know tangent is sine over cosine, so it'll be sine squared over cosine squared. And at that point, then the cosines cancel, and we're left with just sine squared equals sine squared. And we verified that. We already verified the last one. We are done. Now, before I talk about even and odd identities, I want to show you guys a few things on the unit circle. So right here, even and odd identities. With sine, it's saying if we have a negative value of theta, we will get the opposite answer. Okay? If we have a negative value for cosine, we still will get the same answer. And with tangent, the opposite answer is what we get. They each match up with a reciprocal. Now I'll explain why this works. So sine, and think if we had sine of theta. So theta is pi over 6. We would go to the sine value. Sine value is y, so we get 1 over 2. Now, the opposite of pi over 6, or the negative theta, would cause us to go this way. Since sine represents the y, that's how much up or down. So if we go the opposite way around the circle, which is the negative direction, it will be down instead of up. So then we get negative 1/2. You see how that's the opposite of what we would have got if it was just sine of theta. With cosine, that doesn't happen. With cosine, pi over 6 would be square root of 3 over 2. If we go the other way, it'll be square root of 3 over 2. And that will just be, square root of 3 over 2, and then it'd be square root of 3 over 2. So that's the same value exactly. Even though it's negative, it's still to the right. If it was 5 pi over 6, that's over here. Negative 5 pi over 6, that's still over here. That'd be to the left. They will be the same, okay? So they will not change. So take a look here, and we can just use our function identities right here to fill it in. So just compare to this. Maybe write this down if you don't have the paper, but you'll get it soon, hopefully. So sine of negative theta, with sine, it is going to become the opposite. With secant, it is just secant theta, and with cotangent, it is the opposite. Okay, the final thing we're going to do. These are our Pythagorean identities we're going to use. And when you hear Pythagorean, I'm guessing most of us think Pythagorean theorem. So a squared plus b squared equals c squared. So for when we have a right triangle with 3 sides, obviously, if it's a triangle. So the hypotenuse is always the longest side across from the right angle. A squared plus b squared equals c squared. Okay, so now 1 plus cotangent squared. Let's explain why this works, why these trig identities here work. So if we go up here, remember, you don't need to draw this on your sheet, but if we had a right angle, we talked about this back at the beginning of the unit circle, and this is a right angle, and we know the unit circle, what makes it the unit circle, it has a radius of 1. So the hypotenuse here is 1. Now sine represents the change in y, up and down, so that would be this side is sine of theta. And cosine represents change in x, so cosine of theta. And we know then that it is a squared plus b squared equals c squared, so sine squared theta plus cosine squared theta equals 1 squared. And that is our identity right here. Okay, now we can manipulate this to get this. If we subtract sine squared, this second one is just the same as the first, but it's in a different order. We manipulated it. We subtracted the sine squared. The third one, instead of subtracting sine squared, we subtract the cosine squared. So all 3 of these are the same function, just in a different setup. Now we could do the same idea to find tangent squared and secant squared, and then the cotangent squared and the cosecant squared. I'm not going to. If you want to talk about that, let me know, and I'd be happy to talk about it. So even though this is 9 identities, it's actually really only just 3, and then they're rewritten 3 ways each. So back to the original here. 1 plus cotangent squared. So we look here, 1 plus cotangent squared right here is cosecant squared. So that is all we do. Next one, sine squared theta plus cosine squared theta. You might remember that. That was the first one we talked about, equals 1. Okay, secant squared theta minus 1. Secant squared theta minus 1 is tan squared theta. Now on example 13, 1 plus sine theta and then 1 minus sine theta. To solve this, this doesn't match up with one of our identities, but we can make it if we use FOIL. So first, 1 times 1, outside, minus sine theta. Inside is plus sine theta. And last would be minus sine squared theta. Okay. Now, hopefully you can see the sign, negative sign and positive sign will cancel. We're left with 1 minus the sine squared of theta, which if we go back to our list right here will equal the cosine squared of theta. So that is it. There is a short Delta Math assignment. If you need help, please reach out. I'm happy to help you, but I need to know that you need help. So talk to me. Hope to see you guys soon and hope you have a great day.